Hey, morning class. Just want to talk about some of the questions that you guys do have trouble to deal with in calculus, especially for chapter 4, the chapter 4 study packet. So someone asked me about those questions earlier today for number 11 and 13. Well, actually number 13 and 17 on the chapter 4 study packet. And chapter 4, it's all about applying derivative for optimization problems, linear approximation, and also the Newton's method. So we'll take a look at that for number 13. Okay, so let's see. And number 13, so here's what we got for the equation. So y equals negative x squared plus 3x, and then plus 18. It's all over negative x plus 7, and the given interval, it's from negative 3 comma 6, so from negative 3 to 6. So according to the instruction, you want to determine if the Rolle's theorem can be applied. If it can, find all values of c, and that satisfies the theorem. If it cannot, explain why not. Well, according to the Rolle's theorem, so one thing that I need to check. Okay, let me just write down Rolle's theorem. So for f of x, it's going to be continuous. It's continuous on the closed interval. And then f of x is differentiable. And also the other requirement, f of a is the same as f of b. So if one of those conditions fails, so that means we cannot use the Rolle's theorem. So what happens if all three requirements are all true? So that means f prime of x. So that equals 0. So we can solve for x. So the value of x is going to be the value of c. So now let's check this. So we do know that this one, is that a continuous functions? Well, we do know that x cannot be 7. So if x equals 7, then that's not going to be continuous. But the thing is that it's on the closed interval. So 7, it's outside the interval. So this one is totally fine. So f of x is continuous on the closed interval from negative 3 to 6. And another thing that I want to check is f of x is differentiable. So let's check that. F of x, is that differentiable using the quotient rule? So we do have negative 2x plus 3 times the quantity of negative x plus 7. Okay, excuse me. Let me just fix this. So negative x plus 7 minus the derivative of negative x plus 7. So then that'll be negative 1 times the numerator. So negative x squared plus 3x plus 18. And it's all over the quantity of negative x plus 7 square. So it is differentiable. So this one's y prime. Another thing that I want to find out, so f of a, so f of negative 3, would that be the same as f of 6? So negative 3, plug in negative 3, so we do have negative 9, because negative 3 quantity squared, that's 9, times negative 1, so negative 9. Plus 3 times negative 3, so minus 9, plus 18, all over. So negative 3, so 3 plus 7. So this one turns out to be 0 for f of negative 3. What about f of 6? Would that be 0 as well? So we got negative 36. 3 times 6, then that'll be 18. Plus 18. Again, it's 0 over. So negative 6 plus 7, quantity square. This one's going to be square. So it's going to be zeros again. So actually, the function is satisfied all those three conditions. So once the function satisfied all those three conditions, so what we can do, we can find the value of c. Okay, so I need more space for this. So let me just erase the definition of the Rolle's theorem. So now what we're getting right here, it's that the value of c. So how do we find the value of c? So we set the derivative equal to 0, so that means negative 2x plus 3 times negative x plus 7 minus, so negative times negative, positive, minus quantity of x squared minus 3x minus 18. Okay, so that one's minus 3x minus 18 all over the denominator, negative x plus 7 quantity squared. So this one set that equal to 0. So the only thing that we can set equal to 0 is just the numerator. So that means this part right here, the numerator, is going to be 0. So try to FOIL it. So we got negative 2x times negative x, 2x squared. Negative 2x times 7, negative 14x. Minus 3x, inner product. And then 3 times 7, plus 21. And then minus x squared minus negative 3x plus 3x. Negative 1 times negative 18, positive 18. So set that equal to zeros. So we do have x squared, combine the like terms. So this one's negative 17x plus 3x. Then that'll be negative 14x. 21 plus 18, then that'll be 39. So set that equal to 0. And it looks like this one, it's not factorable. So we got 3 and 13, but this one we need to end up with negative 14. So if this one is not factorable, guess what you can do? You can use the quadratic formula, or you can use or you can complete the square for this to solve for x. So using the quadratic formula, we got 14 plus minus square root of negative 14 quantity square minus 4 times 1 times a, which is 1, times 39. And then it's all over 2 times 1. So make sure that the solution is going to be in the intervals of negative 3 to 6. If you find out the solution is outside the interval, then that's not going to be the value of c. Okay, so try to verify this and see what that is. So most likely the solution is going to be considered positive and negative, but see which one that belongs to the interval. Negative 3, it's right in between negative 3 and 6. Okay, so now let's see what the other questions that you have right here. So the next one, we do have number 17. It's a word problem. And that one, I think it's optimization. Okay, let's see. So according to the instructions, so solve each optimization problem. So a rancher wants to construct 2 identical rectangular coral. Okay. So rectangular coral, it's like this. And using 400 feet of fencing. So that means the circumference or the perimeter is 400 feet. Okay, so 2 identical, so that means we need to cut it off into 2 equal portions. And the rancher decide to build them adjacent to each other. Okay, adjacent, that means right next to each other, so there's no gap right in between. So that they share fencing on one side, so that's where what they share, the fencing. And what dimensions should the rancher use to construct each coral so that together they will enclose the largest possible area. So one thing that we notice that we do have width, width, and width. And then this one, we can just say that it's L, and here's L. So the area of this rectangular wrench, so then that'd be considered length times width. And then the perimeter, we can set it as 2L plus 3W. So that means for the auxiliary equation, we do have 400 equals 2L plus 3W. And now one thing you need to be careful with this, for the main equation, we do have 2 variables. Again, area, that's just considered constant. So length and the width. So those are the 2-dimensional variables. So now we need to solve for one of those variable in terms of the others. Okay, so in order to solve for L in terms of W, we need to isolate L by itself. So subtract 3W both sides, and then divide it by 2. So that means 200 minus 3/2 W equals L. And then whatever the equation that we isolate with the variable, we need to put it into the main equation. So that means the area. So that equals the quantity of 200 minus 3/2 W times W. And now this one is the main equation. If this one is the main equation, that means we need to differentiate it. So before you differentiate it, you want to simplify the whole thing. So 200 times W is 200W minus 3/2 W squared. So that's the area of this coral. And now we take the derivative of a constant area, then that'll be zeros. Derivative on the right hand side, then that'll be 200 minus 3/2 times 2, then that'll be 3 W. And now we want to set that equal to zeros and solve for W. So that means W equals 200 over 3 feet. And now let's see what else that we need to find out. The length. So for the length, we just plug in a number. So 200 minus 3/2 times 200 over 3. Cross cancel. 200 reduce. So that means the length would be considered 100 feet. So we find the length and the width. So length, it's 100 feet, and then W, 200 over 3 feet. Okay, so those are the questions that you guys have on the Chapter 4 study packet. Again, any questions that you have regarding the practice work, homework, classwork, anything, so just put into send me the email or put in on the YouTube comment, and then I'll try to set up the video for this. Okay, so thank you for watching it, and I'll see you guys next time.